Okay. Remember this topic. This is when you need to add more than just two vectors. Okay. The idea is that you recognize what are the vectors that are making up the whole exercise. So this exercise goes like this. A person starts walking uh, in the position A. Okay. That person walks 20 meters in the northeast direction at 30 degrees. Then that person walked 30 meters going north. Then the person walked 40 meters to the west, sorry, and then that person walked in the southeast direction 20 meters until it reached to the point B. So I wonder, what is the resultant? Sorry, what is the resultant of the person's walk? Okay. Um, when I ask for the resultant, or when I ask for the sorry, I can't find something. What? Oh, sorry. So I wonder about the resultant. I want to know what the resultant is. The resultant is, in other words, the resultant is going to be the difference between the first, the initial position and the final position. Okay? So basically, for this exercise, the resultant is going to be that distance that you see over there. I mean, from the origin to the final position. That's basically the resultant. So I wonder, what is the resultant that that person had? So we identify all the vectors that are making up the path that the person followed. As you can see, because we have four vectors, we're going to have, okay, the path was divided in four parts, so we're going to have four vectors, okay? You can call them with letters, or you could call them with numbers. It doesn't matter. Now take a look. I like to call them with letters. Even though my points are indicated to be A and B, I'm going to be using letters for the vector, okay? So I'm going to call the first vector, I will call it M. I don't know why M, but I don't want to call it A because this point right here is named A, okay? So I'm not going to call it with the same name. So this vector, I'm going to call it M. The second vector, I will call it N. O, and P. Okay, that will be my first step to name each vector. Now, remember what we do in the first place.
Miss,
Yes?
did you? Oh, sorry, it's an O. I thought it was the sign of an angle. Sorry.
Ah, no, that's an O. Maybe like that. It's different, okay? No, beautiful. That's O, and this is, no, wait, this is theta. not too different, to be honest. But yeah, that's a no. Okay, so what we do in the first place is we locate all the vectors in the table of components, okay? Remember what we do. We list all the vectors and we get each component. Remember that the angles, if they are horizontal angles, you're going to be using for x cosine and for y sine. What do I mean when I say horizontal angles? Horizontal angles are the angles that are taken or measured from the x-axis. For example, this angle 30 is being measured from the x-axis, okay? Because this is the x-axis. So the angle is measured from the x-axis, so I could say that this angle is a horizontal angle. Now, for our horizontal angles, or angles measured from the x-axis,
Cosine.
I'm sorry, what did you say?
Cosine.
For x, I'm going to be using cosine, and for y, I'm going to be using sine. But when my angle is measured from the y-axis, it changes. Remember that we care about the position of the angle. If the angle is measured from the y-axis, then my x component will be using sine, and my y component will be using cosine. In this exercise, you're not going to see this, okay? Because my two angles are measured from the horizontal. The angle of 45 right here is also measured from the horizontal. This is a horizontal line and the angle is measured from there. So we also say that this is a horizontal angle. But this really doesn't matter, okay? So we start drawing the vectors that are making up our problem. So my first vector, which is m, okay, my first vector is this one, and it has an angle of 30 degrees. My second vector, n, is going up like this, okay? Now, I didn't write the what the vector is. The first vector measures 20 meters. The second vector measures 30 meters. I don't need to write the angle over there because I know that it's going straight upward. So my angle will be 90, and you know that I do a one-step process in this kind of vectors. The third vector, which is the vector O, is straight horizontal going to the left, and it measures 40 meters. The fourth vector, which is P, now this is interesting, but in any case, it is moving like this. Take a look, I'm drawing the vectors in the exact same way they look, and my angle is located here. Now this last vector, vector P, measures 20 meters. Now for those vectors that have angle, I'm gonna need to get the components. Okay, so my for my vector m, the first vector, my x component is going to the right or is it going to the left?
Right.
Right.
To the right. Okay? And the y component is going up or down?
Up.
So this will be my, and the one below will be mx. The green is going to be the x component and the blue will be the y component. I'm gonna make it a little bit smaller. Honestly, I don't know how well you see my whiteboard because of my TV. It doesn't
Yes,
have.
we can see it well.
No, it's
Oh,
okay.
oh, okay, because I don't see it very nice, honestly. I mean, the screen quality, if I compare it to the one that my laptop used to have, it has less quality, so I don't see very nice. But in the iPad, I see very nice, but not in the screen, not in the whiteboard, not in my TV. So I really hope you can see it nice. Okay. Now, I will get the components of my vector P. I don't need to get components in N and O because those are straight vectors. Okay. So my component in P is going to the right or to the left?
To the right.
In P,
To the left.
Right.
Repeat.
P. Mm-hmm.
It's going to the right.
To the
Right
right.
and down.
The horizontal component is going right or left?
Right.
It's going to the right. Take a look. If you throw something in this direction, that something is going to go to the right but also down. So my x component is going to the right. And the y component, as someone said it, it's going down. So this is going to be py. This defines what is the sign that each component is going to have. So the x component, because it's going to the right, is going to be positive. Remember this. To the right means positive, and to the left means negative. Up means positive, and down means negative. Well, you're not seeing it, but it's there. Okay, now it's there. Okay, yeah. So the x component, because it goes to the right, the answer will be positive. Okay? And my component here, as you can see, is next to the angle. Is touching the angle. The angle is right here. Okay? So it is touching the angle. We say that the x component
Is adjacent.
touching means adjacent. And if it is adjacent means that we're going to be using cosine. So mx is going to be equal to 20 meters times cosine of the angle, which is 30. How much is this?
17.32.
17.32 meters. Again, I repeat, this is positive. Okay? So positive 17.32 meters. That will be my first answer. My second answer, which is the y component, as you can see, my is going up. Okay? So it's going up, so it's going to be positive. Now, the my component is in front of the angle. Okay? Is in front of the angle.
It's opposite.
Means opposite, and if it's opposite, it's gonna be sine. Okay? So you say my is going to be equal to 20 meters sine of the angle, which is 30. And y is equal to
10.
10 meters. And as a reminder, remember this is positive 10 meters. The vector n, is it moving horizontally?
No.
Why? Vertical.
It's just moving vertical. Therefore, it's just 0. Okay? You could totally ignore this because it's not moving horizontally. Now, the vertical component is just the same vector with the sign indicating the direction. Because it's going up, my direction is going to be positive. So you're just going to write the vector will be plus 30 meters. As you can see, no procedure, but won't be necessary. Then we have the vector O. Vector O is not moving vertically, okay? Just moving horizontally. Because it's not moving vertically, this component is going to be 0. Remember, it is just moving horizontally. So we say that we could totally ignore this part. And now remember the x component. This one is going to the left, and if it goes to the left,
Negative.
the sign for the x component, take a look, is negative. So here you will indicate that this vector, because it goes to the left, is negative. So in the end, you're just going to write the negative and the vector. Negative 40 meters. I like to highlight the negative, so I'm going to put it in different color. Because I like to highlight the negative. I want the negative to look different. Because I'm blind. That's the reason. Now we move into the last vector. We have P. Px, we already defined that Px is going to the right, therefore will be positive. And Px, take a look, is touching the angle. My angle is right here, okay? And as you can see, it's touching the Px. My angle here is touching Px, okay? So we say Px is actually touching the angle. If it touches the angle, means that it is adjacent. And if it is adjacent, means that you will be using the trigonometric function cosine. So to calculate px is going to be equal to the vector, which is 20 meters, times cosine of the angle, which is 45. Px is equal to
14.14 meters.
14.14 meters. And now we work with Py. Py is right there. And as you can see, it's in front of the angle. Because it is in front of the angle, Py is going down, so my sign is going to be negative, first of all. Then Py is in front of the
Opposite
angle, so it's going to be opposite. And if it's
sign.
opposite, we use sine of the angle. So we say Py is equal to the vector, which is 20 meters, times sine of the angle 45. And because the angle is 45, the answer will be 14.14.
Negative.
And because it's going down, it's negative. We only have 4 vectors over here, so we can say that this part we're not going to use it. Okay, we're not going to use it because we already finished with the vectors. So now all we do is we're going to add each column separately. First, I will focus on the x component. So I'm going to add all these numbers. 17.32, 0, 40, and 14.14.
Negative
Negative
8.54.
8.54.
Negative 8.54 meters. Now we do the same with the y component. We're going to add the 10, 30, 0, and negative 14.
25.86.
25.86 positive. Now we apply the formula for the resultant. Okay, so we say resultant is equal to the square root of negative 8.54 meters to the second power plus 25.86 meters to the second power. This is equal to the square root of, how much is that?
741.67.
741.67
67.
square meters. Okay, now we're going to apply actually the square root. So the square root is going to be cancelled with my unit. And the square root of that answer is
27.23
27.23 meters.
meters.
Remember, we try to see if it makes sense. As you can see, the 27.23 meters is greater than x and also y, okay? That's an analysis that we do with the answer. If it's greater than the two individual components, then at least it makes sense. And then we apply the formula for the angle. So we say that the angle theta is going to be equal to arctangent of y, which is 25.86 meters, divided by x, that is negative 8.54 meters. We cancel meters with meters. And this gives you how much?
Negative
71.73.
71.72 degrees.
And with this, we finish. In other words, means that the resultant, the total displacement that the person had was 27.23 meters. And how do you measure this angle? Remember I told you where the resultant was. The resultant is going to be this. Okay? So that is the resultant. Now, the angle is negative 71.72 degrees. The reason why the angle is negative is because it's going clockwise. That's why. That's what the resultant means, and that's what the negative in the angle means. Now, I'm not going to ask you to draw the resultant, okay? But next year you will do it. Because yes, next year you again see vectors. Apply to